Okay, key pieces we need to put in about 1, 2 through 1, 4. Intercepts and symmetry, an equation of a circle from 1, 2 through 1, 4. Starting with the intercepts. Finding intercepts. You got x-intercepts or you got y-intercepts. An x-intercept is a point where the graph crosses the x-axis. You find it by plugging in 0 for y and solve for x. The y-intercept, point where graph crosses the y-axis, and you plug in 0 for x and solve for y. Our example here, find the x-intercepts and y-intercepts of the graph of y equals x to the third minus 4x. Okay. Start with, let y equal 0. So plug that in, and then we got x cubed minus 4x on the right-hand side. Well, we can factor out an x. That leaves x times x squared minus 4. X squared minus 4 factors into x minus 2 times x plus 2. Now what makes each of those factors 0? 0, 2, and negative 2. So our zeros are at, our x-intercepts are at 0, 0, 2, 0, and negative 2, 0. To find the y-intercept, let x equal 0. So we'll plug that in, and that right-hand side just simplifies to 0. So the y-intercept is just 0, 0. Okay. And we can see that on the graph. The next part is symmetry, and you see something already popped up in the video. X-axis symmetry, graphical, it's wherever xy, that point is on the graph, then x negative y is on the graph too. Looks like this. Okay. If you fold along the x-axis, they match up. For y-axis symmetry, if we have xy, that point on the graph, then negative xy is on the graph too. So if you fold along the y-axis, they match up. Origin symmetry, wherever xy is on the graph, then negative x negative y is on the graph too. That's if you spin around the origin, they will match up. Now how we find those algebraically, we replace y with negative y yields an equivalent equation for x-axis symmetry. For y-axis, replace x with negative x yields an equivalent equation. And for origin, if you replace x with negative x and y with negative y, we get an equivalent equation. Working through that, y squared equals x cubed minus 4x. Plug in negative y. Negative y squared is just y squared. That's an equivalent, so it is symmetric with respect to the x-axis. Y-axis, plug in negative x squared happens to be x squared, and so that is symmetric with respect to the y-axis. Origin, plug in negative y and negative x. On the left we get negative y, on the right we get negative x cubed and then plus 4x. Divide everybody by a negative 1, that gets us back to y equals x cubed minus 4x. So it is symmetric with respect to the origin. Equation of a circle. Well, first off we have the distance formula for between 2 points. If you have the point x1, y1 and x2, y2, the formula for finding the distance between those 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Basically, that is the Pythagorean theorem in coordinate geometry. And so the standard form of the equation of a circle with a point xy lies on the circle of radius r and center hk if and only if x minus h quantity squared plus y minus k quantity squared equals r squared. So we want to find the equation of a circle with the center at negative 1, 2 and a point on the circles at 3, 4. So there's our picture. Now to come up with the equation, we know h is negative 1, k is 2. We need to figure out the radius. So the radius will be the distance between those 2 points because we have the center and a point on the circle. Otherwise we'd have to find midpoint. So x2 minus x1, well that's going to be 3 minus a negative 1, and y2 minus y1 is going to be 4 minus 2. So that gives us 3 plus 1 or 4 and 2. 4 squared is 16, 2 squared is 4. That gives us square root of 20. So if I go plug it into the equation of the circle, we get x plus 1, because x minus a negative 1 is x plus 1, squared, plus y minus 2 quantity squared equals the square root of 20 squared. Square root squared cancels. And so we have x plus 1 quantity squared plus y minus 2 quantity squared equals 20. Parallel and perpendicular equations of lines. Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. If we are given a line that passes through the point 5, negative 2, and 2, 10, we want to find the equation of a line that's parallel and perpendicular that goes through the negative 8, negative 4. First, I need to know the slope of the given line. So find how far apart, how much it rises, how much it runs. So 10 minus a negative 2 over 2 minus 5. 10 minus negative 2 is 12. 2 minus 5 is negative 3, so that's negative 4. So the parallel line will have a slope of negative 4. Perpendicular will have a positive 1/4. First, we're going to use point slope form, which is y minus y1 equals m times x minus x1. And so plug in our slope and our ordered pair. So we get y minus a negative 4 equals negative 4 times x minus negative 8. Simplify, that gives us y plus 4 equals negative 4x minus 32. Then minus 4 gives us y equals negative 4x minus 36. We could have also used the slope-intercept form, which is y equals mx plus b, and we plug in mx and y so that b is the only one left. Simplify, gives us negative 4 equals negative 2 plus b. Solve for b, which gives us negative 2 equals b, and then write it in slope-intercept form. So y equals 1/4 x minus 2. And then for 1.4, we're looking at domain and difference quotient. First off, you always look, is the domain given? No, then we ask the question, does the function have an even root? Or yes, then we just state the domain. If it no, does the function have an even root? We have yes or no options. If it's yes, then we set what's inside greater than or equal to 0 and solve. If it was no, we ask the question, does the function have x in the denominator? And we've got yes or no. Okay. So back to the even root, we take 4th root of x plus 3, we take x plus 3 greater than or equal to 0, solve. We get x greater than negative or equal to negative 3. So the domain of A, well, domain of this example is x is greater than or equal to negative 3. If it had x in the denominator, we take the denominator, set it equal to 0, and solve. And our domain is x can't be that value. And if we said no all along, then it's all real numbers. Difference quotient, one of the basic definitions in calculus, employs the ratio f of x plus h minus f of x over h, where h is not equal to 0. That ratio is called a difference quotient. We want to work that with our particular example. One of the easiest ways is to take each piece of it and figure it out and then plug it into the difference quotient. So start with f of x 4 plus h. So we plug in 4 plus h for all the x's and simplify. So 4 plus h times 4 plus h is what 4 plus h squared is. Negative 2 times 4 plus h, well, I can distribute the 2, that's going to be 8 plus 2h. And then 4 plus h times 4 plus h is 16 plus 8h plus h squared. And then distribute the subtraction and then simplify. So we've got an h squared. We got 8h minus 2h is 6h, and 16 minus 8 is 8, plus 9 is 17. And then f of 4, well, that's just going to be 4 squared minus 2 times 4 plus 9. That's 16 minus 8 plus 9, which is just 17. Now plug it into the difference quotient. So we put h squared plus 6h plus 17 for f of 4 plus h. We plug in 17 for f of 4. Simplify, the 17's cancel. And then we can simplify again. On top, we can factor out an h. And then the h on top cancels with the h on the bottom, so it simplifies to h plus 6 with h not being equal to 0. That's the quick and easy for the first part of Chapter 1.